ins and outs of gRPC, and actually not Akka Serverless. We're actually changing the name, and I'll talk a little bit about that throughout my presentation, and how it all works out there in the wild, respective of the product that we're offering around gRPC service development or microservice development within the context of a platform as a service product. But again, my name is Jeremy Pollock, VP of Product and Developer Platforms at Lightbend. And before I kind of get into it, I'll give you a little bit of preview of what I'm going to be talking about today. And I thought today I'm here to talk about how we use gRPC. We're huge fans of gRPC. We leverage it quite a bit within the context of the open source project called Akka, which has been out there for the better part of a decade. And it certainly is a key part of our new product. We were calling it pretty much as a code name, Akka Serverless, as we were testing various things out in the market. We're now converting that to a new name called Kalix. I'll set it up around what that product actually does, irrespective of the problems it solves, and then dig into the details of the gRPC usage and implementation. And then, of course, if time permits, give a quick demo of the product. Now, I'm going to describe a little bit about the company, the use cases, the products, and I feel like I need to do that in order to provide sufficient context. I'm super excited about what we're doing here at Lightbend and what we're doing, especially so with this new product called Kalix. So forgive my enthusiasm, if you will. I'm a product manager as well, although I'm generally quite technical in nature. And so it's hard not to sell my product, but my intent here is not to sell you anything. It's just more to explain how we leverage gRPC within the context of our technologies. And just to set that context around what Lightbend is or who we are as a company, and some of you may have heard of Lightbend, some of you may not have heard of Lightbend. It is the company behind the open source project called Akka, which has been out there for, gosh, now over a decade, and is a JVM-based distributed computing and data management framework that allows developers to build these high-scale applications. Some of them are customers that you see before you right now. Others, since it's open source, are out there in the wild that have never subscribed for more services from Lightbend and perhaps don't even know that Lightbend is the backing company behind Akka. But if you look at some of the customers in front of us right now, if you can imagine a Disney Plus, where you're tuning in for the night, you're looking to decompress and watch some TV, or have your kids watch some TV, understanding who you are, what shows you've recently watched, where you're at in those shows, that state that needs to be managed about that user profile is done through the context of an Akka powered application. If you're a customer of Starbucks and going into the store and ordering some coffee on your phone, even though you're in the store itself, that transaction is going through an Akka-powered commerce platform. If you're hopefully perhaps going on cruises, as COVID hopefully gives us a little bit of a respite from social distancing and the like, but if you're going on a cruise in Norwegian Cruise Lines, they're another great Lightbend and Akka user, leveraging Akka to create, in essence, digital twin representations, leveraging the actor model within the context of Akka to track, what you're doing on the ship, what products you're interested in, whether you want a Mai Tai with your lunch or a pina colada, making different product recommendations. And then as they come back into port, having that data be synchronized automatically to the cloud, even though everything has been running on ship during that time frame, during the cruise. And this, as I said this, but I'll say the words again too, as you kind of read on the slide. But at the heart of what we tried to do at Lightbend and through Akka has been to provide the technologies, the frameworks that allow developers to build these sorts of applications. And if you look at the array of apps, services, and APIs that people had to have built with Akka, it tends to be real-time in nature. So data has to be processed very quickly. Logic has to be executed almost instantaneously in order to deliver these high-end awesome experiences, whether it's for a user or for systems and applications. Now we have 2 products in market, and I'm not going to go through all the words here. I just wanted to make the distinction that Akka is your classic Akka. It's been around for quite some time. Again, over 10 years. We have millions of monthly downloads of the open source project. Ultimately, at the end of the day, though, it's really intended and best used by your very experienced development teams that are coding in Java or Scala. And to a certain extent, that has limited our ability to push out into other markets and help other companies deliver these sorts of types of services and applications that we just touched on very briefly through that customer slide. And that's where Kalix has emerged, is to provide an abstraction layer, a more simple developer experience that allows really any sort of developer to start building these sorts of applications and not have to worry about operations and not have to worry about all of the unnecessary complexity, and to do it in their language of choice, whether it was Java, Scala, Python, TypeScript, JavaScript, the list goes on and on. And where I'm going to spend most of my time on today is Kalix. It is this new product. We went into beta June of last year, general availability in November of last year, and we're going through this rebranding based on a lot of different discussions with users, understanding where they saw the value, how they were best using the product, and ultimately, even though it is built on top of Akka and leverages Akka extensively underneath the covers, it is a different product. It's a different programming model and different programming layer, if you will. And it is a fully managed platform as a service. So we're running it for our users, our customers. It is beyond serverless. And to a certain extent, that's why we moved away from the serverless part of Akka serverless, because ultimately we were seeing it as much more than just a traditional function as a service product, and nothing to be taken away from the likes of Lambdas and Azure Functions. Great technology without a doubt, but for us, we were trying to do more, something different, taking away all this infrastructure that can be complex for many teams, whether it's the database, the event broker, caching, service meshes, and taking that all away and leaving just behind this very simple programming model that makes it very easy and quick for teams to start building out these applications, again, in whatever language they want, and ultimately achieving these high-end applications. So if you can imagine a Starbucks or a Disney Plus or an Eero through AWS or Amazon, these are products and companies that need to deliver incredible experiences to their end users, to be able to process data at high speed and be quite responsive. And that's where this notion of reactive becomes quite critical. And Jonas Bonaire, who is the founder of Akka, founder of Lightbend, also was one of the primary authors behind the Reactive Manifesto. If you haven't checked into it, definitely go check out the Reactive Manifesto. I think the signatures up to this point are well over 13,000 companies and developers that have signed. But anyway, it's one of the key principles of the Kalix product. I've already talked about this, and this is just a better picture, if you will. It's everything from database to what transport protocol I need to worry about between my different sets of microservices or frameworks I want to use, or security layer, or Kubernetes, and operating system. All of that is abstracted away out from the developer, leaving just the business logic that they have to worry about when developing backend APIs and services within the context of a microservices implementation. Just to give you a little bit very quickly, I'm not gonna go through all the gory details here, so I'm just gonna page through these slides relatively quickly here so that we can get to the meat of the presentation. But it is important to note that Kalix is built on top of Akka. So the Akka team has been building out Kalix as well, and we've had great learnings from that development that have actually fed back into the product, the Akka product and the open source project, which has been awesome to see. But of course, Kalix benefits from all these value propositions that we see from the Akka framework today. On top of that is that serverless runtime. So we're running it in our cloud. We're running today on GCP. And in AWS, we have plans for future clouds as well, but it includes all of the right knobs and dials, features, components that development teams can use to integrate their own processes into our runtime environment, and then of course help manage that environment through logging and monitoring. Some things they don't have to worry about, like auto scaling, for example, that's handled automatically by our team and our infrastructure. Some of the key capabilities, and we'll touch on this as we kind of move through the presentation, certainly, but the state is important to Kalix. It's important to Akka. It's one of the great, I guess, features of Akka is how it manages state data at scale, your application data, your application state. Think of the digital twin scenarios in the case of Norwegian Cruise Lines or Disney Plus, for example. But the way that we handle state is quite unique. You still interact with state, i.e. create data, update data, delete data, but you're not having to worry about actual database connectivity and database setup and database schema management. That's handled all automatically for you through our programming model. Communication patterns, whether it's eventing or direct request response or streaming, that's all part of our declarative programming model that I'll show in slides and in a demonstration as well. And we've been targeting some powerful microservices patterns, if you will, out there, specifically event sourcing and CQRS. And those are both natively handled in Kalix. We also have other state models and eventing support as well through integrations like with Kafka and Google PubSub. But it's an event-oriented architecture, supports event-oriented architectures as key parts of the system. And then on top of that, of course, I mentioned this already, so I'm not going to say anything more. It's more than just Java and Scala. We here at Lightbend like to say that quite a bit because to date, if you knew about Lightbend, you sometimes refer to us as the Scala company. We love Scala. It's great. We've been great supporters. We have teams on staff managing, maintaining Scala 2. So without a doubt, we love Scala. We love Java. But we also have seen the need out there in the world to move beyond those languages and building these sorts of powerful applications. So how do we use gRPC within Kalix and within Lightbend and Akka? And I'll touch on all of it, I think. And why I was so excited to be talking to you all today is that we really have jumped in feet first, head first. Anyway, we dove deep into the pool, into the gRPC pool. We saw just in how incredible that technology is and how it can support our own customers' implementations and improve their applications from performance and scalability perspective. So we really have jumped in quite a bit and leverage it extensively, both in Akka and Kalix. We released one of the key libraries in the Akka family, if you will, in the Akka open source project is Akka gRPC. That was released in May of 2018. If you go to the GitHub repo and look at the project and the history, I think there's the Hello World was written by one of our engineers back in May of 2018. In 2019, we made the decision to really use gRPC as a front and center component or technology choice, both for internal service development. So as we're building our own underlying services that support the user's capabilities and functionality, gRPC is native within the context of that backend environment, but also in the front end as well. It is the primary interface, if you will, for users and developers as they develop applications to run within the Kalix environment. On the Akka front, we also shifted to gRPC as our go-to implementation choice for service communication. So as you're building out microservices using Akka and you're looking to communicate back and forth between different services or even the ingress to a particular service, we recommend that gRPC is the primary choice or the initial choice, if you will. We have other customers doing things like leveraging Kafka as well, but without a doubt, we've seen gRPC as a predominant choice within our Akka community since the introduction of Akka gRPC. Now, at one point, and in Akka, we have all of the proof points out there in the world that Akka is quite performant, quite scalable. Time and time again, we've just had either customers or people out there in the wild demonstrate the effectiveness and efficiency, scalability, and robustness of Akka. Now, right around the time there was a benchmark for gRPC clients or libraries that was produced, and right around that time when it was published, our team, our Akka team, the ones that were building the Akka library, were also noticing some performance issues within the context of Kalix development. And I think that's one of the great benefits of Kalix and building on top of Akka is the fact that we learn immediately what's working, what's not working. And so right around that time, the benchmark result came out, we were also starting to investigate. But that said, we were, our Akka team, our engineers are really, really smart, really talented and motivated to fix things. When they dug into the benchmark and looking at the performance of the library, they definitely found some issues and opportunities for improving performance and scale. And without a doubt, there's a blog post out there written by one of our engineers where he steps through the details of what we saw and how we responded and delivered much better performance. I think it boiled down to, if I remember the blog post correctly and summarizing it in my PowerPoint bullets here, was ultimately our initial implementation was very focused on streaming and assuming streaming. So we were opening up a stream to a service, sending data, receiving data. We were not necessarily focused on the more conventional, I guess, usage model, at least for people that are more familiar with REST APIs. That typical REST, or it's not REST, of course, but the request response model where you send some data in, you expect some data to get out, and then you move on with the rest of your application. So as we looked at the code base, we recognized that we were really focused before this point on optimizing for streaming behaviors. We sat down and approached what do we want to do with streaming or non-streaming requests and responses, and that led to a tremendous improvement in performance. Numbers are numbers. I'm happy. The slide says we're number one. None of us here at Lightbend or Akka are sitting here going, oh, we're number one and we're number three. I'm happy to be in the top 10, top 5. Everyone's benchmarks can vary, so we're not sitting here saying these are absolute numbers. We look at the numbers as more directional than anything. But most important, I think we were really excited about the ability to optimize our gRPC library for customers out there in the open source world, but of course also for our Kalix users as well. So within our Kalix environment, and I'm not going to go through this, lots of boxes on the slide, but this is a close approximation of how the back end looks like if you peeked under the covers of the Kalix code base and operational environment. And it's actually out of date in some regards, but the key point I think here is that any communication that's happening between these components, between these services, is happening through gRPC. So everything that we're doing within our core infrastructure, core set of services that's powering Kalix, this platform as a service that runs out there in the cloud, that's all happening through gRPC. So heavy use, without a doubt, across the board. And we see this as one of the key ways that we achieve the performance and scale that we've seen in our own performance tests, just testing out the Kalix set of services. We also use gRPC and Protobuf, of course, for API development to power our front end and client applications. So these are the experiences that developers would use to manage their own use of the Kalix application. So this is our console, the web UI. It talks gRPC web to APIs that are defined, of course, in Protobuf. We're compiling it. I screen grabbed on the right-hand side part of the repo in my VS Code, but if you went and poked at the the inspector in a browser, you would see it as well. But ultimately, we love it. I've been in the API business for a while now, better part of 13 years, I think, and have seen the value of APIs. I was mainly in the REST world before Lightbend, but we just went recently through a rebranding, renaming, and in the case of the console or the web application, a re-architecture of the front end application. And just as you would expect from a contract first API development process, we were able to quickly create a new version of the front end, talking to the gRPC backend APIs, and obviously leverage existing tests and just move very, very quickly since we had broken those two apart and leveraging the Protobuf to drive that front end client application. We also see and use Protobuf for the CLI. The CLI actually is our primary user experience for interacting with the service in production. So when you create a project, deploy a service, you're using the Kalix CLI. And just like our console, we're using a gRPC and Protobuf for contract first API development. Without a doubt, this has been a game changer for us and enabling us to move very, very quickly in introducing new changes, refactoring things as we need to, adding new capabilities to rapidly innovate within the context of these user-facing applications. We also use gRPC web UI as part of the CLI. So this is actually one of the first points in time where a user of Kalix, so a developer who signed up with an account, perhaps one of you who's checking it out, either right now or after this meeting, if you built a service, and we'll do that as part of the demonstration today. If you build a service, you can actually proxy that service, deploy it to production and access it from local environment through the gRPC web UI without having to open up an insecure connection to our production environment. So it's a nice way for secure local development without having to, again, expose your gRPC endpoints over the internet in a naked sort of way, if you will. So to this point of the presentation, it's been really focused on gRPC within the context of the product, the inners of the product, if you will. Again, we're leveraging the core Akka gRPC library that is found in the open source project. We're leveraging gRPC web and the compiled Protobuf output files. In our front end application, we're using, again, those same Protobuf and additional Protobuf and gRPC endpoints in our CLI. And of course, we're using the gRPC web UI as part of the developer experience when testing out those services and APIs that you're building with our gRPC focused service. Of course, the question now becomes, well, actually, what does this mean to a developer who wants to build a gRPC endpoint? And let's dig into that now. So how do you build a service, an API? And it's a pretty simple, straightforward process. I'm going to step through the slides very quickly and then just show you actually building one from scratch and deploying it in my local environment. Well, deploying to production, but developing it in my local environment. We start with the specification, the API contract. Protobuf is the schema that we're using to declare your schema, declare your API request response signatures. Everything that you're basically doing from an API perspective is defined in the Protobuf. We have some annotations that we've added in to support tying the Protobuf to underlying capabilities in the product, but without a doubt that API first development is key to our product. And let me just dig into that a little bit. And you're probably all, I'm assuming you're all, well, maybe I shouldn't assume, but I'm assuming at least some of you are heavy into Protobuf and understand this Protobuf set of messages. But and I'll go through my example in development. But ultimately, we're sitting down, as I said, thinking about how do I want to expose my functionality, what API methods am I going to support, what are the inputs, what are the outputs, and what is the schema, the state model, the state that I want to manage within the context of Kalix. Now, this one shows gRPC alone. There are annotations for HTTP transcoding. There's also annotations for doing things like eventing. So if you want to leverage event sourcing and have other services subscribe to the event journal, or if you want to use Kafka for a messaging environment as well, you can also create topics automatically within the context of this Protobuf and connect those topics between services all through this declarative programming model. Once we define the API, we have to actually choose the state model, assuming I want to create a service that manages data. We have there are really 3 state models supported right now. One is event sourcing. The other is a key value store, which I'll demonstrate today. We also have support for CRDTs, conflict-free replicated data types. And it's really simple to change, to pick and choose. So it's not a large lift and shift effort if you want to go from key value to event sourcing, or event sourcing to key value, or CRDTs, for example. So it's a really nice way to manage your data. For key value, it's pretty straightforward. I mean, I think all of us can probably quickly grok a key and a value type of data mechanism or data storage. From event sourcing, it's still as simple pretty much as that within the context of Kalix. And I think that's where anyone who's been involved in event sourcing has gotten really excited about Kalix, because they just see this as a very simplified programming model that taps into the power of event sourcing, but without having to have all of the expertise in event sourcing in order to get going. And then last but not least, you actually do something more than just write Protobuf in Kalix. Once we have our API, our state model, we can do this from scratch. I'll use the code generation process that comes as part of the Kalix product to generate stubs for our functions or the API requests that we handle. But ultimately, I go in and for each one of my RPCs, the API requests I'm going to handle within the context of my service, I can sit down and write my code. Now, what's really important to note is that within the context of my function, my logic that I'm writing within Kalix, the notion of state is treated a little bit differently than what developers typically expect. So typically, if you're building an API, you're setting up a route, and you're going to say, okay, given an incoming route with this type of request, I look for an ID perhaps, or I look for some other parameter. And if their API request is asking or supposed to store data, then I'm connecting to a database, setting it all up, making sure all of my, not necessarily always in the same code path, but I think you get my point that in a traditional model, you're really thinking quite clearly about a route coming in, and then determining if I have to create something, and then sending it to the right place or the right part of my database. Excuse me. Within the context of Kalix, state is delivered to the function. So if I'm updating my shopping cart, I don't need to worry about, based on the incoming ID, and fetching the cart from the database somewhere. That's handled automatically by the product. So and let me just kind of quickly do my build here. What really happens under the hood is that as an incoming request comes into the Kalix execution environment, or execution cluster, we have, in essence, what we call a state proxy that rides alongside. It's a sidecar proxy that rides along with the user code that you've written, your business logic. And that state proxy is doing all of the distributed state management and providing other abstraction layers on top of the things like message brokers, service meshes and the like. And that state proxy ultimately takes that request, determines which entity, which data object you're looking to interact with, and then it passes that data to that user code. So it becomes very efficient and performant when interacting with data, whether it's creating, updating, or deleting data within the context of this distributed environment. And okay, and this is another view of that. It goes beyond the traditional model of a stateless function, if you will, or function as a service, where typical, this would be the model where event comes into a Lambda or an Azure function, you do something, and then you spit out another event. And of course, if you have to interact with the database at that point, you're doing that within the context of the stateless environment. We provide a stateful runtime environment, and as the event comes in, that proxy that I talked about, that state proxy that's doing all the heavy lifting around state management and other operations, gets the state at the point in time, puts it into the user function, and then all the user has to worry, the developer has to worry about in their code is emitting that data, emitting that state, and we automatically handle the saving of it into the backend database. Okay, so let me actually show a demo, and let me stop stop sharing and share my entire screen, since that is what I need to do, and get into VS Code. And I believe you can see it. Okay. So I'm in VS Code. I'm going to use Java. I'm not a Java guy. I think I used Java way back, maybe 15 years ago. I'm using it now more at Lightbend for sure. I'm more of a Python developer, JavaScript developer. I have been dabbling in Scala just because I'm here and I've got Scala experts to help me along the way. But today I'll just do Java. We have a Maven command that I can run that will basically allow me to create a new project. And so let's go ahead and set that up. And then go into my project and let's look at it. Okay, here we have, this is this is really, it's a starter project. We've got an initial protobuf, just to give an example, counter API. So it's a simple counter, nothing too elaborate within the context of a microservices environment. It's, hey, I want to increase value of a counter, decrease value, so on and so forth. You'll notice this is a protobuf file, of course. We have our messages, which are representing, in this case, our incoming commands or requests, the input data, as well as the output data as well. And then we go down to our service, which is ultimately the API that will be run within the context of Kalix. I'll come back to the code gen in just a second, but we've got ultimately our API calls, an increase call to increase value, decrease value, reset value, and get current counter. Right here, this part right here is all about code gen, and this basically will generate, in this case, Java stubs, if you will, that allow us to start coding exactly where we need to be coding, respective of our business logic. That domain is our state, and this is defined in our domain protobuf. Simple state model in this case is just, a value, a number, if you will, that will be tracking as part of a counter. So let me go ahead and compile this, and what will happen if they're, on first run, it will take those protobufs and do the magic of code generation and generate some Java code for us. And if I look at our Java file, and there's a main class that basically just kicks off the service. And if I add more and more components to my service as I can, or as I want to, I can do that. Of course, the heart of this particular demo is this counter class, which is ultimately the thing that will allow us to encapsulate the business logic for receiving the incoming events or commands like increase value or decrease value, and then of course emit the state to update the database as well. Now, I'm not going to be showing off my typing skills. I'm going to be showing off my copy and paste skills. So I'm just going to go to a file that I have over here. Since we, as you can see, lots of not implemented yet, but let me replace that with a more fleshed out example. And key parts here is, for example, that increase command. So increase is going to get mapped to this increase request or API call or method. And you'll notice as the inputs are the current state and the command. So the command, again, is what we define in that protobuf as being the input to the API. And the state is that data model that we've been tracking or defined in that domain protobuf. And again, this is that current state. When it's passed into this method, I, as a developer, I'm always assured of the fact that it's the most current data that's being managed within the context of Kalix. And so there's no fetch of the data. It's delivered to me in the function. And in this case, basically just saying, hey, let's set a new state to be equal to the current state plus the value passed into the command. And then as an effect, we'll spit out, in essence, an event that will update that state. For getting a current counter, it's just basically building up the right data and passing that back out into our Java code. So let me go ahead and deploy that. So I could run this locally if I wanted to. In this case, I'm just going to deploy it to our production environment. I've got there's a Maven command, in this case, since we're in Java, that will deploy this package up the code. So we're leveraging containers within our runtime environment. So it's not a copy your Java code and paste it into a text UI in our application. We're using containers to execute the logic or the applications that you develop within the context of the Kalix product. I love real-time demos. The one thing I forgot to do is update my Docker image so that it can deploy to my Docker Hub account and then ultimately deploy to Kalix. So again, we're using containers. Right now it's packaging up into a Docker container. It will then deploy to a registry, and then it will tell Kalix, the production runtime environment, to deploy itself. So it'll grab the container from whatever registry you're using and put it into our Kubernetes environment. So we're leveraging, as you saw from the first kind of architectural slide I've had out there, we're leveraging Kubernetes extensively within the context of Kalix. We don't leak Kubernetes to you, so you as the developer don't have to worry about Kubernetes. We're doing that all underneath the covers, but we are using containers and in this case Docker to package things up and then deploy them out into production environment. So we now see that our service has been packaged up and deployed. This is actually that Maven command is running this CLI command to deploy that service to my account. And now if I wanted to, I can do a Kalix. In this case, again, Kalix is the CLI. I will take advantage of this local proxy to attach to that service running in production. So again, if you're building an application that should not be accessed by the public, if you will, you can certainly choose not to expose it and just connect to it through this local proxy. And that's what I'll do right now. And that'll give us an opportunity to test out the service in the gRPC web UI, which hopefully has come up in our Google Meet. And so if I do my decrease and test 1, Now this should return an error because, of course, we haven't implemented that per my copy and paste code. But if I wanted to increase the value of test 1, and let's increment it by 10, then we have a success. And let's do get current counter. Because you can see I've been doing some demo preparation, but we increased it by 10. Let's do it for another test 1. Let's do it increase by 30 and get counter. Now we have 70. So, you know, lots of other things to look at. I suggest if you're interested in learning more about Kalix and what it can do for gRPC powered development, then 2 resources to go look at right now would be the docs.kalix.io site. So definitely check that out. You can also go to console.kalix.io to register for a free account, and that can be done today if you want. We're still transitioning in the renaming. So the actual Kalix.io site is not active. That'll be available in a couple of weeks, but the actual documentation and the console is fully available and ready to be tried out by people that are looking to learn more about building stateful applications within a cloud-based environment without having to worry about all the complexity that you would normally be worrying about when developing these sorts of high-end microservices applications. And with that, I will stop my screen. I'm just going to leave up my those 2 links just so that we have them up here if you're interested in checking out the sites. But then I'll open up for questions.